Howdy folks, today we are looking at a OctoPrint plugin that I've been working on that does some fun stuff. Right now you can see it's tracing the part, so it's actually moving along and probing, and every time it touches the part it gets a new reading of where that edge is. So right now it only works on rectangular stock, but the vast majority of the time that's what you're starting with. So this is all set up with a electrical probe. What you see in the end of the mill there is just a standard end mill flipped upside down, so it's got the shank of the mill pointed out. So that's just a pretty reliable 3/8 inch piece of bar stock as far as that matters. And the vise is electrically isolated from the rest of the mill, so therefore whenever the probe there touches the stock, it completes a circuit and the control board knows that they're touching. And so therefore, with a little bit of logic, which you can look through on GitHub, which I'll link in the description if you're interested, it can walk around the entire piece of stock, figuring out all of the dimensions as it goes. I've thought about making this more efficient, having it just go up and touch the stock and then drag along, as long as the probe stays in contact, and then it knows when it gets to the other side, because the probe, comes off and disconnects from the piece. But I have a few concerns there around, what if the sides aren't very straight and things like that, and I don't want to be marring up the workpiece. So now this is let's see what we're going to look at here. Yeah, it's going to finish up here, show the dimensions of the piece, and then we're going to look at the offsets. This is something I actually just finished putting together last night. So, before we do that, we're going to just show, this is showing the probe offsets. So now it's going to, even though the probe can only touch the sides, it's going to go and center over each of the corners here, just to show that we know where all of those points are. It's already taking into account the diameter of the probe in order to be able to center itself directly over the four corners of the workpiece. But what if our cutter is a different size? And so you can see here we're going to enable cutter offsets for the moves. And if you look at the mill diameter up there, that's a 3-inch mill is what it's set for now, which is pretty big for this machine to be able to get out all the way. So let's actually take that down and pretend we're using a 1-inch end mill, and we'll reset here on that bottom left corner. So you can see now where we're floating 1/2 inch, so half of the diameter from the corner, and you'll see the same thing on kind of as you go around the stock. So here it'll just walk around, and so if we had a 1-inch cutter on here, it would basically be just grazing the stock all the way around here. And this enables us to say, okay, here's my cutter size, go to the edge, and then come in some amount from the edge, and we don't have to worry about doing all of the manual calculations around the size of the cutter. And that'll make it a lot easier to cut out the T-block that we've been poking at here in this project. So now the last thing I want to do is just show that we can go and find the center of the piece as well, because we know where the sidewalls are, so it's pretty easy to find the middle. And this will help us set up the threaded hole in the middle of the block, which will help us put in that offset hole. We know that the offset hole on the T-nut that we're making is 2 millimeters off from the middle. So yeah, that's about what we've got for today, and we will see you next time.